Hello everybody, am I audible to you guys? Let me know that I am audible to you or not. I hope that I am audible to you. Yes? Yeah, so please let me know through the message that I am audible to you. Visibility is also clear to you. I hope that there is no technical issue. Just give me a confirmation so that we can move ahead, guys. And also tell me who is watching me live. Just give a thumbs up or just drop a message that I'm watching live. I'm watching live. Sir, for me, lectures are not showing. Okay. Let me check, guys. Anushka, there is any problem at your end? Anushka, you are able to join the class? You are able to join the class? सर एक बार ग्रुप देखना, टेलीग्राम ग्रुप। बच्चों को कुछ इश्यू आ रहा है सर, एक बार ग्रुप पे विजिट करना। हाँ सर, इसमें कुछ बच्चों को लाइव दिखा नहीं रहा है। एक बार आप ग्रुप पे उनका स्क्रीनशॉट देख लीजिए एक बार, अपने जो टेलीग्राम ग्रुप है। ओके ओके सर। ओके। Okay, hello everybody. Everything is okay now. Are you able to watch me live? Yes or no? Please let me know through the message. Now, are you able to join the live class? Yeah, please tell me that now you can watch me live or not. Okay. For Muhammad, it's clear. Yeah. Now, for another Muhammad 53, Anushka, Senthil, please let me know. Yeah, Anushka, are you there, beta? Okay. Okay. Okay, guys. So I think everything is fine now, and I think we can start our class, right? So again, good evening, all of you guys. I hope that you guys are doing very well, and some new students are now part of the this batch, and these are the new joinee. So first of all, welcome to the new joinees, guys. And the first step, that is, you can see the first step is always the important step for any kind of a new start, whether it is of preparation, whether it is of starting any new business or anything. First step is a very important. Okay, so congratulations that you completed your first step in your this gate preparation, right? So I'm just giving you a very small, you can say, the intro of what we are doing here, and what is this all that, right? Classical thermodynamics is a one subject. Complete thermodynamics having the two parts in the chemical engineering. One is classical thermodynamics, another is the solution thermodynamics. And these are the first subject that is going on, which is classical thermodynamics. Its weightage in the GATE examination is 4 to 5 marks. Also, the classical thermodynamics knowledge is mandatory to understand the solution thermodynamics and also the heat wala part, right? Okay. Now, in the 19 lectures, up to the 19 lectures, we have done the zeroth law, first law, and the second law, right? It is clear to you. And now we are moving ahead to the, you can say, the another part in which we are discussing the entropy kind of things. Okay, I'll try to use the terminologies in the common terms so that new joinee can understand those terms. But yeah, after the lecture, I'll connect with you guys, and we will, you can say, see that how you can clear your backlogs so that you can continue with the live lectures, or you can say that covering your subjects parallel with the live class. Okay, so let's start our class, guys. So in the last lecture, we were discussing the TS diagram, right? T means temperature, S means the entropy. So we were discussing the temperature entropy diagram. Guys, like Senthil, Muhammad, I know that there are very less chance to understand what is going on because it's lecture number 20. Okay, but don't worry, just today your task is to just listen me, don't write anything, just listen me, guys. Okay, if you want, you can write in the your rough notebook, and you can try and whatever we are doing here, but just listen to me today right? And just try to understand what I'm saying. That's it. If you are understand the things, then it's very, very, very good. And if it's not, if you are not able to understand the things, then it's okay. Do not think like that. Okay, things are not, you can say, for me now, why I'm not understanding these things, because it's like this lection number 20, guys, right? It is not possible to start anything from the 20th step. It is always start from the first step. Okay, so we are discussing the TS diagram, means the temperature and entropy diagram, or you can say the temperature and the entropy graph. Okay, so temperature will be on the y-axis, entropy will be on the x-axis. This is the graph we will see. First, we will calculate the TS diagram, or we draw the TS diagram for the isobaric process. Isobaric process means where the pressure is constant. That's why I write here that pressure is equal to constant. So this kind of graph we will get. Another will be the isochoric process. So we plot the TS diagram for the isochoric process, and isochoric process means volume will be constant. Okay. The third thing will be the isobaric and isochoric process. You can say the comparison of the diagram. So if you can see the diagram of the isobaric and diagram of the isochoric will be similar, right? The similar diagram. But when we plot these two graphs in a single TS diagram, then how can we figure out that which one is for the isobaric and which one is for the isochoric? So that we will figure out with the help of the slope. Okay. So for the isobaric, slope will be less, and for the isochoric diagram, slope will be more. More slope means the curve will be steeper. Okay. So in these two curves, this curve will be the more steeper. That in this way, or you can say this is how we can say that this graph, or you can say this curve is represents the isochoric, and similarly this is represents the isobaric. After that, we will discuss the TS diagram for the isothermal. Isothermal process means temperature constant. Okay. Isothermal means temperature constant. So it is very simple. This is the TS diagram for isothermal, means temperature will be constant. So we will get only the horizontal line in the graph, right? Because this horizontal line represents that every value of the entropy, my temperature will be constant. So at S1, you can see the temperature is T1, and the S2, you can see the temperature still T, right? So this is the TS diagram for the isothermal process. Again, that is for adiabatic process. So in the adiabatic process, my entropy will be constant. My adiabatic, entropy will be constant. So entropy remains constant in the adiabatic process. Okay, it is clear to you. Now, just try to understand one thing. If I will give you an example, let's suppose we have a system, right? Okay, and this is any one body, and this is any two body two, and this is the adiabatic. The system is adiabatic. Adiabatic means that there is no heat exchange at all. Okay, the heat exchange is zero in the adiabatic process. Okay, so adiabatic process means what? The heat transfer is zero. Okay, heat transfer is zero. There is no give and take of the heat. We are not going to take heat, or we are not giving to the we are not giving heat. That is called adiabatic process. This is the adiabatic. But in between, let's suppose in the body 1 and body 2, if there is a heat exchange, guys, there is a heat exchange, then entropy will increase or decrease of these two bodies. I hope that you are understand my point. If the heat exchange is between body 1 and body 2, then the entropy of the body 1 and body 2 will change. Okay. Okay. So after that, we draw the TS diagram for adiabatic expansion. So in the adiabatic, we are having the two kind of processes, guys. One is reversible, or you can say it as the frictionless, and another is the irreversible. Irreversible means the friction is there, right? Friction means, I hope that you guys are aware about it. Due to the friction, heat is generated. Yes or no? If you are going to rub your hands, then you feel the warmness in your palm. How? Due to the friction. So due to the friction, heat is generated. So the process which is reversible, so we termed the reversible as a frictionless process. So in the frictionless process, there is no extra heat. Adiabatic process means that there is no heat exchange. It is clear to you. Also, it is a frictionless process, so the extra heat is also not going to generate. In that case, my entropy will be constant. So see this diagram, TS diagram. So this vertical line stands for what? That entropy is constant. If you will see the entropy value at this temperature, let's suppose it is my T1, entropy will be S, and at this temperature, if the temperature is my T2, at T2 temperature also the entropy will be S. So temperature is changing, but my entropy will be constant. Okay. After that, we discuss the TS diagram for the Carnot cycle. So we have the four processes of the Carnot. Two are the isothermal and two are the adiabatic, right? Now we know how to plot the TS diagram for each case. Like for isothermal, we know. For adiabatic process, we know. So if we club all those four processes, then how I can plot the TS diagram for the Carnot cycle? So Carnot cycle having the four processes: isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression, right? And due to that, we just plot this diagram. After that, we discuss the TS diagram for throttling process. So new joinee, just understand this. Throttling process means that it is the isenthalpic process. So in the lecture number, I think 11 or 12, you will have the lecture which is dedicated to the throttling process. You will get to know that what is the throttling process. But for now, just understand it. If we pass any fluid through a narrow space, I'm saying again, if you are passing any fluid through a narrow space, in this process, the enthalpy will be constant. Enthalpy will be constant, right? That is my throttling process. So H is basically stands for the enthalpy. The symbol of enthalpy is H. So H formula is equal to U plus PV, where U is the internal energy, P is the pressure, V is the volume. So throttling process is isenthalpic process, means H is equal to constant. So through this method, we just get the value of the throttling, and in throttling process, if ideal gas is throttled, then if the ideal gas is throttled, guys, then with the isenthalpic, this process is isothermal also, means temperature is also not going to change. Okay, so this is the horizontal line we can draw for the throttling process. It is clear to you. So these are the previous thing. I hope that you guys understood the things. I think that it's need of a quick revision so that you can cop up the topic. Now I want to now discuss this thing for the polytropic process also. So please put the heading polytropic process. Polytropic process. Right? Polytropic process. Now let's understand what is the polytropic process. We already did this part, polytropic process, right? So first, polytropic process equation is in terms of P and V. It is PV raised to power n is equal to K. Okay, where your n is nothing but it is the polytropic index. It is your polytropic index, guys, right? It is clear to you. Now you know that if we need the delta S and all these value, we need del Q, so that we can divide T and we can convert this ratio into the change in the entropy. So what is my task now? My task is to calculate the heat exchange in the polytropic process. Right? It is clear to you. So in one way, we already did this part, work done and the heat exchange in the polytropic process. Now, in other terms also, we will calculate the polytropic process so that we can draw the TS diagram. Okay, so if I will say about the heat transfer, just write the equation of the first law. First law of thermodynamics says that whatever you give the heat to the system, that heat is going into two parts. First, the part which is converted into the work done, and the second part which is change the internal energy of the system. Very simple. Whatever heat you will give to the system, that will going to change the two terms. First, the work done which you are getting from the system, and second is the entropy of the system will change. Why? Because you are giving the heat to the system. So let's suppose any process which is going from 1 to 2. Let's suppose any process which is going from 1 to 2, then I can write this equation as the heat transfer from 1 to 2 is equal to the work done from 1 to 2 plus the internal energy change from U2 minus U1. I hope that it is clear to you. Okay. Also, I think I can write this, that the heat transfer from 1 to 2 is equal to the work done from 1 to 2 plus delta U. I can write the delta U. This is the formula, Cv delta T. I hope that you guys are aware about it. Delta U, change in internal energy is nothing but it is the Cv delta T. So for the two temperature, I can write U2 minus U1 as Cv T2 minus T1. T2 minus T1. I hope that there is no issue in that. Okay, I hope that there is no issue. Done. Now, the heat transfer from 1 to 2 is equal to work done in the polytropic process. We already calculated this, guys. It is similar to the adiabatic process. P1 V1 minus P2 V2 divided by, in the adiabatic it is gamma minus 1, right? But here the process is polytropic, so instead of gamma we will use the N, which is the polytropic index. So it is my N minus 1. This is the work done in the polytropic process. Okay, so the new joinee, this formula we already derived, bacho, right, for the work done in the polytropic process, right? So don't worry that this is calculated like this. We already derived this term in the previous lectures. Okay, so do not think that how this term can write directly. Now it is my Cv T2 minus T1. Okay, so now P1 V1 minus P2 V2, and I hope that this is the 11th class thing. PV is equal to RT. For 1 mole, we can write PV is equal to RT. Okay, can we write P1 V1 is equal to RT1? Also P2 V2 is equal to RT2. So if I will replace this P1 V1 P2 V2 value here, I can write this equation as, just pay attention here, the heat transfer is equal to P1 V1 minus P2 V2 means that RT1 minus T2, right? RT1 minus RT2, R gets, we can take common, T1 minus T2, divided by N minus 1 plus Cv. Now what I can write for the Cv? See, let's try to understand. I know for ideal gas Cp minus Cv is equal to R, guys. This is for the ideal gas. Okay, this is for the ideal gas. If I will divide the Cv to the whole equation, Cp by Cv is the gamma, minus 1 is equal to R by Cv. So from this equation, can I write Cv as r divided by gamma minus 1. Tell me if you have any hurdle, right? There is no need to hesitate. Okay, so the first rule in my class is do not hesitate to ask the doubt, right? I'm here for your doubts, guys. So ask the doubts as much as you can. Believe me, if you are throughout the year, if you are engaging, if you are interacting with the teachers, then believe me, guys, then there is no, you can say, force which can stop you to get the good rank. Okay, so do not think so much while asking that out, just say it. Okay, and it's up to us that how we handle that doubt. Don't worry, nobody will tell you that why you are asking these silly doubts. No teacher will say this, guys, so don't worry about that. Okay, so yeah, tell me now that this is clear to you or not. Please tell me. After that, I'll start the next part. In the north, there is a, you can say, um, I don't know how, it's April itself, but it's kind of a rainy season. It's kind of monsoon in the north. I don't know about the south. Yeah, Senthil or Muhammad, I think you guys are from south. So, what is the weather of your south? Because from 15 March itself, it's kind of a monsoon in the north, guys. And it's all because of us, because we are ruining our environment. So environment will pay off whatever we basically give to the environment, right? We are chemical engineers, guys, and it's our duty to save our environment. Okay, so just try to save our environment, just by doing anything, any small, you can say, if you can do the small change that can save the 0.0001% of environment, then do it without thinking. Okay, it's too hot. In the north also, it's the April month, and in this month, you can say that uh, generally we basically start the ACs and normal summer season, right? Okay, okay. It means that except this year, we also start the ACs, you know, or cooler, fan, all those things just. And but now this year the environment is something, the weather is something like that, that we are not putting our you can say the warm clothes inside. Okay, अदरवाइज अब तक तो हम जो है पूरा एकदम अपने जो भी वुलन क्लॉथ्स हैं सब पैक करके रख देते थे. And yeah, Senthil and Mohammed, you guys can understand Hindi little bit. Let's suppose if I want to crack any joke, देखो, so that, like, it may be possible that I could not crack that joke in the English. Okay, so are you guys able to understand the simple language, or you can say the simple, you can say the things in the Hindi, or you don't know the Hindi completely? Okay, you don't know Hindi completely. Okay, okay, okay. Because some of my South friends are working with me, and those know the Hindi very well. Even they uh, speak in the Hindi very well. Okay, no problem. Okay, so I hope that this manipulation is clear to you, right? So if you will pay attention, then this is the CV. This is my CV, right? And if I'll take this CV on the left hand side, then I can write CV as R by gamma minus 1. I just put this R divided by gamma minus 1. Okay, that's it, nothing else. Okay, now I think you can see the similarity R T1 minus T2, R T2 minus T1. There's something, you can say, similarity in both the terms, so that we can take some common. If I will write this T1 minus T2. It means that we have to take negative sign outside the bracket. And let's suppose I'll put negative sign outside the bracket, and it is T1 minus T2, and I take the common R T1 minus T2, and just write the terms which is left. 1 divided by n minus 1 minus 1 divided by gamma minus 1. Okay, so this is the thing. Now R T1 minus T2 is equal to, what is this? Just write take the LCM and all that, n minus 1 and gamma minus 1, and which is my gamma minus 1 minus n plus 1. So 1 gets cancelled, and my heat transfer value will be R T1 minus T2, right? And gamma minus n divided by n minus 1 and gamma minus 1. Okay, that is clear to you? This is the value of the heat transfer. This is the value of the heat transfer. So do not worry about it. We will write this big formula into the small terminology so that we can remember easily. Right? So what is it? Just let me handle this. First, you just write these things and tell me so that I can use the next slide. Okay, now see, I will write this equation in a specific type of you can say the pattern, right? So that it's easy for us to understand this. See, it is my gamma minus n divided by n minus 1, okay, and it is my gamma minus 1, right? So I am writing this gamma minus n divided by gamma minus 1, okay. So gamma minus n divided by gamma minus 1, okay. And what is the left term, guys? Left term is R T1 minus T2 divided by n minus 1. I hope that it is clear to you that what is this formula. This formula is nothing but it is the work done for the polytropic process. Yes or no? So it is gamma minus n divided by gamma minus 1, and it is the work done from 1 to 2. So just remember this formula in this way. Remember this formula in this way. Okay, it is clear to you, and it is also you can say the similar. It is gamma. Okay, minus n minus 1. So you can use your trick to you can say understand this. This is the way I can write it, and I can remember it very easily. Okay, now another term in the another pattern also, I'll write it as important. In another term also, I'll write it. So do one thing. We'll try to write this formula in the internal energy terms. Okay, in the internal energy terms. So you can say in terms of internal energy. Right. See, whatever we know now, whatever we discussed previously, that is our foundation, and I am going to use that foundation only. I am not going to use any new single thing, guys. I just use whatever we learned. If you will get any new thing, then just let me know, sir. This is the thing you did not taught us. Okay. So like it transfer from 1 to 2. It is my, I can write it as n minus gamma. Okay, n minus gamma. And it is my n minus 1. N minus 1. Okay. Now this minus sign can absorb here and it can write as R T2 minus T1 divided by gamma minus 1. Divided by gamma minus 1. I will tell you the importance of these patterns. Right? If you remember, what is this? R divided by gamma minus 1 is CV? Yes or no? So what is it? It is my CV delta T. See, what is this now terms? This is CV. And what is this? This is my delta T. So this is what? It is my CV delta T. CV delta T means the delta U. And if it is T2 minus T1, it means that it is U2 minus U1. Yes or no? So this whole term is equal to U2 minus U1. Okay. Now I will write that it is my n minus gamma divided by n minus 1 multiplied by U2 minus U1. This is the another pattern. The first one was gamma minus n divided by gamma minus 1 multiplied by. So these are the two formulas. Means formula is same, but what is the importance? If you have the internal energy data, then use this formula to calculate the heat transfer. If you have the work done data, then use this formula to get the heat transfer for the polytropic process. Now it's turn of how to remember this. Sir, we can confuse in the sign that it is my n minus gamma or gamma minus n or what it is. It is very simple. Just in my time, how I just you can say that the search, you can say that trick to remember this. See, it is very simple for me. First of all, if you will see the similarity, here it is n. You have only the two terms, n and gamma. So it is n, here also n. In this formula, it is gamma, it is also gamma. So similarity is there. So if it is n, so it is very simple that you have to minus gamma. And if it is gamma, it is very simple, you have to minus n. Right? And in the denominator is minus 1, minus 1. If you all start with gamma, then it is my minus n divided gamma minus 1. If you start with n, then n minus gamma divided by n minus 1. Now, so how I will remember that for this term, I have to multiply with the internal energy or I have to multiply with the work done? It is also very simple. How? See. You can remember like this. This is my technique. You can use your technique if you are good at that. So it is my n, C, n, and it is my internal energy. These are symbolically just opposite. Yes or no? If you will see the U, it is the, you can say that the opposite of the symbol wise, it is opposite of the n. Yes or no? It is clear to you? ये ऐसे है और ये ऐसे है. This is how you can remember this. This is how you can remember this, right? So now just take your, you can say just take your rough page and try to write this formula. Just try to write this formula, okay? Go with my trick. So I can write, if I have the n, then n minus gamma, n minus 1. Now, yeah, should I write w or should I u? No, I should write u. Why? Because n is the opposite of the u. another formula will be automatically, you can write it is my gamma minus n divided by gamma minus 1. If it is this, then it should be the work. I hope that you like this trick. Okay, and if you are very good to find out the tricks, then it's very good. And also tell me also that so that I can pass on the other students also. Right? Done. It's done to you guys. It's done to you. Okay. Please write all these things and also tell me Anushka and Mohammed, because you guys are uh, watching these lectures from the start. Why we need the heat transfer? Why I just very desperate to find out the heat transfer? Why? Why I'm very desperate to find out this? Yeah, Askar, is it clear? Now it's okay, great. So because why I'm interested to find out that Q, first of all, I hope that topic is clear to you, that we are going to calculate the delta S equation, right? Like in this slide, you can clearly see this is my throttling process and this is my ds value. For ds value, formula will be del q by del t, sorry, del q over t. ds, to find out the entropy change, we have the equation ds is equal to del q over t. So for that purpose we need del q. That's why I basically put so much effort to find out the delta q for the polytropic process also. Now we will discuss the ts diagram, which is our main mode. How much work is converted into heat to find out efficiency of a machine. uh, that is the different part. Okay, you are okay, you are you are, you can say, right, Anushka, but just I was actually asking in this context that whatever the topic is going on, in that context I am asking that why we need the q. Why? Because we are interested to calculate the ts diagram, and for the ts diagram we need the heat value, right? So we know that ds is equal to del q over t. What is the heat transfer value? Heat transfer value is this. So I can write this value in the you can say differential format, that it is my d. In the differential format I can write this. This is in terms of change now. This is in terms of complete change. And one step above this is n minus r gamma divided by n minus 1, and it is my du. It is my du, right? So this is the value of q, and I have to divide with the t. I have to divide with that, and n minus gamma divided by n minus 1 du is nothing but it is my cvd. Du is my cvd divided by right? So if you integrate this thing, then it is my s2 minus s1. If you will integrate the ds from process 1 to 2, from state 1 to 2, and it is my c n minus gamma divided by n minus 1 and cv. All these things are, you can say that all these things are constant, and it is my dt over t from 1 to 2. It is clear to you, yes or no? So it is nothing but it is my s2 minus s1 is equal to n minus gamma divided by n minus 1 multiply cv multiply by ln t2 over t1. This is the final formula for the entropy change in the polytropic process. Okay. Write it and tell me that, yeah, Senthil and Mohammed, please let me know. The new join, just let me know that you are getting some, you can say any, you can say that 30% you are getting, or 20 or 5% you are getting. Please, new joinee, just tell me guys that, yeah, no, Mohammed, I'm not asking to you, the new joinee, I'm asking to you guys that, even 5% is, you are getting the 5%, because I'm using the terminology which is not heard by you actually, you know, because we are at the 20th lecture, but still, uh, because ultimately you have to start with the lecture 1. Okay. 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 Yeah. Because yes, actually there is a some lag between uh, me and you. Okay, कुछ second का lag है. There is a some lag in a seconds. That's why I receive the can say your message late. Can we move forward? Okay. See, I know, I already knew this, that you guys are getting only the 1%, only the words actually, like heat, work done, process. At least you just getting some terminologies only, you know. It's okay that you are not getting this maths, this not getting these equations, no worry, because it's your first day, and but still you are familiar with the some process. I'm saying it is polytropic, it is isothermal, it is this and that. When you read from the lecture 1, then you will recall it. Okay, sir, I'd say sir was saying something about this process, right? So that was your, that will be very helpful for you that when you go through your backlogs lecture, right? Okay. So yeah, this is the things. Now just let's try to understand. Uh, so Now the task is to plot the TS diagram. Okay, I think this is the thing which we are doing from the process one, from the isobaric process. First we get the S2 minus S1 value. After that we plot the TS diagram. So for the TS diagram we need the slope. So just take this equation. ds is equal to n minus gamma divided by n minus 1 cv dt by t. So ds is equal to n minus gamma divided by n minus 1, that is my cv dt by t. Okay, and for that purpose we need dt divided by ds. This is the slope actually. This is the slope actually. So it is my n minus 1 divided by n minus gamma, and it is by t divided by cv. This is the slope actually, guys. This is my slope, right? So this is positive, right? And n can be anything actually, right? N can be anything, like in the adiabatic process n is equal to gamma. N is equal to gamma. So in some process n can be less than gamma, n can be greater than gamma. Let's suppose if n is less than the gamma, in that case this thing will give us the negative thing. So if for that part, if we for the negative slope, if we you can say write the TS diagram, then this kind of TS diagram we can get. Let's suppose I'm saying that heat is supplied. Heat is supplied. If we supply the heat to the system, you know that expansion process will happen. Expansion takes place. Expansion takes place, right? And if expansion takes place, we know that work done is obtained. Work done is obtained, right? And you know that if expansion takes place, then temperature will drop. Temperature will drop, guys, right? It is clear to you. And if you are giving the heat to the system, then entropy must be increased, because Q is equal to TDS. Q is equal to TDS. This is a constant, no worry. But if you are increasing this, then entropy will increase. Entropy will increase. So for this method, how I can write the TS diagram? So this is my S, this is my T, right? So this kind of graph I'm getting. Okay, T is not basically constant, so it means that we are getting curve, and this is the process. You can say from 1 to 2, my entropy will continuously increase and temperature will drop down. Temperature will drop down. Is clear to you? Okay, this is the in case of heat supply. I'm saying if heat is rejected, if heat is rejected, if heat is rejected, in that case, you know that in what case heat is rejected? In the case of compression. In case of compression, compression will be there. In the compression, what will happen? In the compression, what will happen? My pressure will increase. My pressure will increase. If my pressure will increase, in that case, temperature will increase. Temperature will increase, right? It is clear to you. So if heat is rejected, then we know that entropy will decrease. Then entropy will decrease, right? So this kind of TS diagram we can get. Entropy will decrease, temperature will increase from 1 to 2. Right? So, this is the TS diagram topic. This is the TS diagram topic. Okay. So this is the topic, guys. Okay. Now, please put the heading Maxwell's relation. Please put the next heading Maxwell relations. So in this topic Maxwell relations, I will use the mathematics actually. So whatever the things which we have discussed, we will use those things only. We will not talk about the other things. And even you can say I'll just use the mathematics. So these are some relations which is very, very important for us. So this topic is also very, very important. You can get the question directly from this topic. You can get the question directly from this topic, right? Now, at the start of the lecture, I told you that in the thermodynamics or in the BTech thermodynamics, specifically in the classical thermodynamics, basically we will discuss the thermodynamic properties. There are a number of thermodynamic properties like the pressure, like the volume, like the temperature, right? Or like the internal energy denoted by U, or like the Gibbs free energy denoted by G, like the entropy, like the entropy denoted by S, like the enthalpy denoted by H, right? So these are the properties, and we will discuss these properties. We will try to calculate these. We will try to calculate the value of these properties. This was my statement, if you remember. And also I told you that for us, the important properties are pressure, volume, and temperature. We will talk about the PVT, you can say, throughout the thermodynamics. Why? Because PVT, these three properties are, you can say, these are the observed property, or you can say the measurable property. Sir, what is the meaning of measurable? You can directly measure the pressure, you can directly measure the volume, you can directly measure the temperature. Let's suppose I am interested to find out the temperature value. I will use the thermometer and get the direct value of the temperature. There is no issue. Let's suppose I want to know the pressure value. I will use the gauge meter and I can get the value of the pressure directly. There is no issue. It is the directly measurable properties. But whatever the properties you can see in this, like U, G, S, H, these are not measurable. These properties you cannot calculate directly. These are the derived property actually. You have to derive these properties. For example, if I want to know the U, if I want to know the U, or if I want to know the H, right? If you want to know the U, what is the value of U? you can write anything. Or like if I want to know the value of H is equal to what? U plus PV. Also we can convert U in terms of the PV and T. So derived properties are derived with the help of the measurable properties like PV. Yes or no? Also I can write U as a, you can say that your Q minus W, and W is PdV, right? This is also PV. So derived properties are calculated with the help of the measurable. These properties are not calculated directly, right? It is clear to you. So we have to basically take the help from the measurable property, or you can say from the PV and T, right? So now we will try to build the relationship. Now we will try to build the relationship between the measurable property and the derived property. Now we will try to build the relationship between the derived property and the measurable property, so that with the help of the measurable property I can calculate the value of the derived property, right? Okay, so I hope that it is clear to you, yes or no? So we do have 4 Maxwell relations. Directly questions can be asked. Directly these relations are used in further parts. Okay. Now see. You have the 4 terms, 4 types of, you can say, energy. You can say like, see, heat and internal energy, right? So instead of internal energy, heat, enthalpy gives free energy, Helmholtz free energy. These are the some, you can say, your derived properties are there, right? Okay, first of all, just I'll take the first law. What will say first law? Del Q is equal to P dV plus du. I will write this directly now, right? Okay, now what is my del Q, guys? Del Q is my TDS. So it is my TDS is equal to P dV plus du, right? And from this equation I can write du is equal to TDS minus P dV. Important relation. I'm not saying just remember this equation. Why? Because you can calculate this equation very easily if you are seeing this lecture, you can say that thoroughly. Okay, if you are seeing this lecture religiously, then it's not a big task for you to calculate du is equal to TDS minus PdV. So du is my TDS minus PdV. So this is my first equation actually, which is important for us. So they can ask the question that which of the following equation is related to the internal energy. This is the equation. From this equation I can derive anything which I want. So I'll use some mathematics here. Let's suppose this is my U is my Z and dz is equal to, let's suppose it is my M and S is my X minus P is, let's suppose, my N. This is a differential equation is there. This is a differential equation actually. This is a differential equation actually. If my Z is function of X and Y, then if I want to find out the value of these, then this equation can be mathematically represented by this. So here Z is my what? Z is my internal energy, X is my entropy, and Y is my volume. M is my T and N is my minus P, right? It is my, sorry, it is my P is equal to my N is equal to minus P. Through the differential equation wala part, I'm writing this for this equation, for this mathematical equation. If you have, see, Z is the function of X and Y. Z is the function of X and Y. and dz is equal to mdx plus ndy, I can write this as partial differentiation of m with respect to the y keeping x constant is equal to the del m divided by del x keeping y constant. Please let me know that you are aware about this equation or not. Please tell me that you are aware about this differential equation or not. Because you uh, have in your first and second semester up to third semester there is an engineering mathematics, and in that mathematics we basically go through the differential equation. No doubt for the gate purpose we also cover the differential equation and all that, but I think that this is the basics, and I hope that you guys are aware about it. Yeah, Muhammad and all the Senthil, are you aware about this? Yes or no? So mathematically, or in the partial differentiation terms, we can write this del m over del y keeping x constant is equal to del n over del n del x keeping y constant. It is, yeah, it's, see, it is very simple. First of all, this is m and dx, so make sure there is nothing to explain in the moment. See, this is, let's suppose z is any your dependent variable and x and y are independent variable. Z is the function of x and y. Means if x or y will, if x and y change, z will change. Like u is the function of entropy and the volume. You can write this as ds, this is the dv. Means that there can be a change in the entropy, there can be change in the volume. If you will change the value of volume or entropy, your internal energy will change. If I will import this equation in terms of mathematics, then I can write z is equal to function of x and y. If x or y will change, my z will be change. Right? So I can write this value as dz. This is the differential equation. dz is equal to mdx plus ndy. And I can, if I want to build a relationship between all these terminologies, then from this equation I can write this. This is the part of the differential equation in the mathematics, so I will use that part. Okay, we cannot, you can say, discuss the maths here. We cannot discuss the differential equation here. I just use a simple thing for in the differential equation. If you are aware about it, then it's very fine. If you are not aware about it, then just you can say that you can say remember like this. Okay, this is the equation. When we discuss the differential equation, you will get this value and you can remember this. Okay, this is the equation which we use in the thermodynamics. Okay, and don't worry about it. If you don't remember here also, then also there is no problem. I have a very quick solution for you. I have a very quick solution for you for that. Okay, don't worry about this. Is just hold on and just let me drive the Maxwell relations. Del m over del y keeping x constant is equal to del n over del x keeping y constant. It is very simple. Means first of all, we will see the change of the m with respect to y. Then automatically x will be constant, and I have to see the change of the n with respect to x, and automatically y will be constant. What is the m? M is t, so it is my del t divided by del y. What is y? Y is my v. Right? Keeping x constant, x means at, s means keeping entropy constant, is equal to del n. What is n? Minus p, so it is minus del p over del x. X is s. Del x keeping y constant. Y is my v. This is, guys, my first relation of Maxwell. This is my first relation of Maxwell. So if you can see this, it is the, if you can see this, guys, then this is the relation of T, P, V and the one derived property, that is the entropy, right? So we are basically build the relationship between the measurable and the derived. Okay, so this is the first equation which we have to remember, and don't worry, in 1 minute only I'll give you one quick trick for this, and you can write all the 4 equations, don't worry. But before that I have to go with the, you can say, conceptual. Second equation will be come from this. See, you now first you have to remember this equation. Second, you have to know that from which equation this equation is come from. Means that this equation is related to the internal energy, right? You have to remember this, that this relation is basically related to the internal energy. Second will be from the enthalpy. Enthalpy is H is equal to U plus PV, right? U plus PV. dH means after differentiation it is my du plus it is pdv plus vdp, right? It is clear to you or not, right? Yeah, dH is equal to du plus pdv is nothing but it is my del q plus vdp. Yes or no? It is clear to you. What is my del q? Del q is my tds plus vdp. So again it is my z, it is my m, it is my y, it is my n, and it is my x. Sorry, it is my x, m dx. No, I will write it thoroughly. It is my dz is equal to m dx plus n d. Again, using that equation, what was that equation? Del m over del y, keeping x constant, is equal to del n over del x, keeping y constant. So what is my del m? M is my t, this is my del t, over del y means it is my del p, keeping x constant means entropy constant is equal to del n, n is v, so it is my del v over del x is my del s, keeping pressure constant. So this is my second Maxwell relation. This is my second Maxwell relation, that is coming from the enthalpy. It is related for the enthalpy. Please write this and tell me if you have any problem in this. If you see U, it means that is for closed system. If we add the U, if we add the PV in the U, PV stands for the flow energy, right? So that will be for the open system, right? I hope that this is clear to you because we have discussed earlier this. Third will be, I think that you are not aware about it because see, in the classical thermodynamics, the maximum discussion will be of internal energy and enthalpy. In the solution thermodynamics, maximum discussion will be of Helmholtz energy and the Gibbs free energy. Okay, so third will be your Helmholtz energy. Right, this is for the closed system because we will not use the H here. So this is denoted by the A is equal to U minus TS. Again, differentiated, dA is equal to du minus dds minus sdt. dA is equal to, what is my du guys? Du is my del q. Del q, what is my du? Del q minus uh, del W. Del Q is TDS minus del W is PdV minus TDS minus SDT. You can cancel this TDS. You have DA as minus PdV minus SDT. Right? Again, what is your M? dz is equal to M dx plus n dy. And if I write directly, then I can write it as del M divided by del x del y keeping x constant is equal to del n divided by del v keeping p constant. This negative sign gets cancelled. And what is the final third relation? Del p over del t keeping volume constant is equal to del s divided by del v in temperature. This is your third relation. This is your third Maxwell relation, which is related to the Helmholtz energy. Done? Done, guys? It's done for you. Okay. Next will be your Gibbs free energy. Next and finally will be your Gibbs free energy. It is denoted by the G. So see, G is nothing but it is my H minus Ts. If you are using enthalpy, then for sure you can directly see it is for the open system. What is the difference in this equation and in this equation? Here it is H and here it is U. Because it is closed, then it is U, and because it is open, it is my H. Okay, dG is equal to dH minus T ds minus SDT. Okay, okay. Now, if you will write dH value, dH is your U plus PV, right? If you write U means U du plus PV. PV means PdV plus VdP minus TDS and minus SDT. Further, you can say break this du and all that. I will directly write the dg value as is your VdP minus SDT. Everything will get cancelled. Everything will get your cancelled, right? So it means that your G is the function of P and T, right? G is the function of P and T. Okay, like here you can see that A is your function of P and T, right? Like that. Okay, again, what I can write this directly, I can write this del V over del T keeping P constant is equal to minus del S over del P keeping T constant. This is your final and fourth Maxwell relation. So Maxwell gave the four relations which basically relate the entropy and PV and T data. Which relate the entropy and PV and T data, right? So now quickly within 1 minute, I'll make you a one trick which is very effective. You can remember this and you do not forget this trick in your whole life. Okay. So you can remember this Maxwell relations very easily, but yeah, Actually, I'll also will tell you that how you can uh, remember that this equation is related to what. Okay, so here it is in change of s and v, then you can write that u is the function of s and v. Here also you can write it is in s and p, then you can h is the function of s and p. Now let me give you the trick. So we have four equations, 1, 2, 3 and 4. So Maxwell's give the four equations, right? And you have to basically remember this equation. Okay, now see what is the trick now. So trick to remember, trick to remember Maxwell relations. Okay, so one word, one in Hindi, one word is there, that is tapasvi. One word is there, that is tapasvi. Tapasvi means, I hope that yogi, I hope that you get this word. Tapasvi means yogi, like जो तप करते हैं, that meditate, or that in the meditation state and all that, that is called in Hindi tapasvi. So just remember this word tapasvi. That's it, nothing else. Now you don't have to do anything. Just remember one thing, that if you are going horizontal, then you have to put the negative sign. See, we have the three properties. What? P, V, T. These are the three properties. Measurable, and one is the entropy, that is S, which is TAS stands for T, PAS stands for P, SES stands for SES, V stands for V. That's it. Now we have to make tapasvi. We have to make tapasvi. So first I have to make tapasvi. Let's suppose I'm writing this ta, pa, sa and v. Simple. I'm go like this. For to making tapasvi, I'm going horizontal. Tapa. बस यही देखना है आपको. You have to check only the first step, that whether you are going horizontally or you are going vertically to making the tapasvi. So it is tapasavi, right? It is clear to you. It is very simple. This is the function in the V, then entropy must be constant, and this is the change in the entropy, then volume will be constant. Done. Now the turn is whether it is plus or whether it is minus. It is totally depend upon that you are going vertically or horizontally. If you are going horizontally, then you have to put a negative sign. See, horizontal signs similar to the negative sign, right? So if you are going horizontal, then means if you are going like this, then you have to put a negative sign. So this is my, you can say, first Maxwell relation. So no, I want to write this tapasvi in the vertical format. Okay, do ta pa. Okay, jana, you see, you have to go like this, or you have to go like this, this. You don't go. You cannot go like this. No, you cannot go this. Just clockwise or anti-clockwise. Right? You have to go clockwise. Just go clockwise, or just go anti-clockwise. Okay? It's nothing like that. You can go anywhere, right? So you are going vertically to make tapasvi. Ta pa, and then this. You don't go like this, right? Ta pa sa. Okay. So here it is entropy and here it is pressure constant. And if you are going vertical, then in the vertical sign will be positive. Sign will be positive. This is my equation number 2. So it's nothing like that. You have to start with here also. You can start with anywhere. Let's suppose I'm starting with this. Ta, pa, sa, v. That's ta, pa, sa, v. Right? Pressure constant. Here temperature constant. Right? and you are going horizontal now. You are going horizontal, so you have to put negative sign. This is my thought. Yeah, Anushka, at your end also video is lagging. At your end also video is lagging. Yeah, Senthil, everybody just let me know that you also facing the same issue. And the fourth equation will be just a, so and B. This is V, this is T. And you are going vertical, then it is positive. This is fourth equation. Yeah, Anushka, everything is clear to you or not? I'm getting video is lagging or not? Okay. So just let me know that all these four equations are clear to you now, right? Just as I promised to you that in 1 minute, I'm giving a one trick that is very effective. You cannot forget this acceleration in your whole life. Just one word, that is tapasvi. That's it. If you are going horizontal, take just negative. If you are going vertical, it is positive. You can start with anywhere. There is no issue. There is no problem. I hope that it is clear to you guys. Yes, please let me know. Yeah, Senthil, Anushka, Mohammad Askar, and everybody who is watching me live, just let me know that up to this is clear to you or not. And for today's, that's it from my side, guys. I hope that you enjoyed this class. You learned, you can see the some concepts, right? And if you have any problem, then you can ask. Otherwise, you can also drop the problem in the Telegram also. Okay, everybody just let me know. Just give me a final message, guys, that this is clear to you. Okay, just drop a final message. Okay, so that's it from my side, guys. Thank you so much for this lecture, and thank you so much. Let's meet in the next class. Bye bye and take care. And Senthil and the new joinee, I'll connect to you in, because there is no class tomorrow. It's Wednesdays are off. So let's connect with the, just call me at 4 or 5 o'clock in the evening, or you can connect with me in the afternoon after 12, right? And we will talk about your preparation, that how we can prepare it and how you can clear your backlogs, right? Okay, thank you so much. Bye bye and take care, guys. Thank you.